Why are these the permutation and combination formulas? What's actually happening here? Let's find out. Welcome to Howie's Hypothetical Ice Cream Shop, where I have 10 different flavors. And today's special, you can pick 3 different flavors and have a permutation cone or a combination bowl. Now, what's the difference? Well, the order matters in a permutation cone because vanilla chocolate strawberry and strawberry chocolate vanilla are going to be different experiences. Whereas a combination bowl, the order doesn't matter, I'm going to give you the same thing. Now, the question is, how many permutation cones and combination bowls are possible? Let's find out. Let's start with the permutation cone. We need to pick 3 different flavors from these 10 flavors. So there are 10 options for the first scoop, and we cannot repeat a flavor, so there are 9 options for the second scoop, and 8 options for the third scoop. And we multiply these together to get 720 different permutation cones. But why do we multiply? We multiply because we are talking about groups of groups. In our example, we have 10 groups of 9 groups of 8. So to figure out how many different options there are, we do 10 times 9 times 8. Now 10 times 9 times 8 is the beginning of 10 factorial. So what do I do to 10 factorial so I only get 10 times 9 times 8? We can divide by 7 factorial. Now what's the relationship between 10, 3, and 7? Well, 10 minus 3 is 7. So we can rewrite 10 factorial divided by 7 factorial like this. And we can generalize this to get n factorial divided by n minus r factorial. So all this says is how much of n factorial we want. Now for combinations, this relies on permutations, except we need to take into consideration the repeated options. For example, all 6 of these now count as one option, because in combinations, order doesn't matter. So we see that every group of 6, or 3 factorial, now counts as 1. That is why we take a look at the permutation formula and divide by 3 factorial, because every group of 3 factorial now counts as 1. And we can generalize this. We have the permutation formula divided by r factorial, because every group of r factorial now counts as 1 since order doesn't matter. So there you have it. Hope this helps.